Hi, so once again, this is a review video tutorial from me. This is not a flip video, but a review video to help you learn something which I actually taught in class. And so this tutorial is on trying to evaluate a trig integrals where you have a cosine or a sine, but both powers must be even. So here we only have cosine and an even power, and here we have both cosine and sine, and the power is even. The power can be 2, 4, 6, but they have to be even. So but if you have a single odd power, then you can use the technique that we taught earlier when the sine power is odd. When, for example, if this is 3, then we could use that technique where we split the sign and then we convert the rest to the opposite and then put u equals the opposite, and that technique. But when we have both powers even, then none of those techniques will work. So the technique that we have actually comes from the double angle formula that we learned in trigonometry. So if you remember your trig class, cosine 2x is actually equal to 2 cosine squared x minus 1. This is one of the three formulas for the double angle formulas for cosine. Now if you solve this for cosine squared, then we would move the negative 1 over to this side, right? And then that'll make the that will kind of isolate this one. So you will have 2 cosine squared x, right, which is this right here, is equal to the 1 goes over to this side, you get 1 plus cosine 2x, and then you divide by 2 and you get cosine squared x is equal to 1 plus cosine 2x over 2. There is a similar formula for cosine 2x used in sine. It's called cosine 2x is equal to 1 minus 2 sine squared x, right? Let me write it down here, which is so similar to that. We have you know cosine 2x is equal to 1 minus 2 sine squared x. And so if you do the same little trick for that, which means you isolate the 2 sine squared x, to do that you need to take the cosine 2x over here and the 2 sine 2x over to the other side. Then you get sine 2x is equal to 1 minus cosine 2x, and then you need to divide by 2. So these two formulas, cosine squared x and sine squared x, right, you should remember. Okay, and and why are we doing this? Now see, we need to integrate cosine squared x, correct? So if cosine squared x is equal to this, then all you need to do is to integrate this. Now 2 is a constant, so it really boils down to integrating this, the 1 plus cosine 2x. But the integral of 1 we know is equal to x, no problems there. And the integral of cosine 2x is actually equal to, what do you think? Sine 2x? Well, it is sine 2x, but it will be sine 2x divided by 2, because there will be an additional 2 coming from right here from the cosine 2x. So the integral of this will be sine 2x divided by 2. Integral of 1 is x, so that's easy, right? And then 2 is a constant, right? So we can take it outside. So integrating this is actually pretty easy. That is why it is much easier than integrating the square. So the philosophy of this technique is that we write the square as a double angle, because it is easier to integrate the double angle than the square. Alright, so let's get started. So we need to integrate cosine squared x. So we write the cosine squared x as 1 plus cosine 2x over 2. Once again, 2 is a constant, so we can take it outside as 1/2. And then we are left with integrating 1 plus 2x. And then when we integrate 1 plus 2x, right, integral of 1 will be x, integral of cosine 2x will be sine 2x over 2. So that's it, and then we are done, right? Okay, integral of 1 is x, right? And once again, integral of cosine 2x is sine 2x over 2. Why do we divide by 2? Because when we differentiate sine 2x, what do we get? Just concentrate on differentiating sine 2x. What do you get? It will be cosine 2x, but you need to multiply by 2. So you get the cosine 2x, but you get an additional 2. So to cancel out the 2, we need to divide by 2. So the integral of cosine 2x is sine 2x over 2. Now let's do, so this is the answer. Let's do a more a slightly complicated one. It's the same technique. There's nothing new here except that sometimes it can be a little pain because you need to keep repeating this technique. Sometimes I call it the shoveling technique because you need, like when you're shoveling snow, you just do the same action all over again. Alright, so let's take this uh, integral cosine squared x and sine squared x, right? So the first thing that I do is I write the cosine squared x as 1 plus cosine 2x over 2 and sine squared x as 1 minus cosine 2x over 2 using the second formula. Sine squared x is equal to 1 minus cosine 2x over 2. Once again, since both powers are even, there is nothing else you can do except to use this technique of double angle formula. Now if you look at this, first of all, there is a 2 here and a 2 here, and then there is a 4, we take it outside. Now if you look at the top part, you have 1 plus cosine 2x and then you have 1 minus cosine 2x. Can you see that, right? That's 1 minus cosine 2x, 1 plus cosine 2x. So that's like a plus b and a minus b. Can you see that, right? So that's like a difference of two squares, correct? A plus b, a minus b, which is the same therefore as a difference of two squares. So it will be the square of 1, right? Okay, square of 1, so that is 1 minus square of the second piece, which is square of cosine 2x. So it's cosine squared 2x. Very good. Alright, so we wrote it as cosine squared 2x, and now integral of 1 is easy, that is just x, right? And we need to integrate 1/4 times, we distribute the 1/4 inside, we need to integrate cosine squared 2x. Okay. Alright, and once again now we are stuck with a even power. So whenever you have an even power, there is no way out other than to use the double angle formula. Now what I have done, now instead of cosine squared x, we have cosine squared 2x. Now let's get back here. When we had cosine squared x, that was equal to 1 plus cosine 2x, right? So x here gives 2x here. So then if you have 2x here, what do you think will happen? Then you should have the double of that, right? Which is 4x. Alright? Okay. So cosine squared 2x would be 1 plus 4x over 2. So if you go back here, right, you will have, instead of cosine squared 2x, you have 1 plus cosine 4x over 2. Now once again, integrating this is not bad at all because we have a 2 here, which is a constant, you can take it outside, and that becomes with the 1/4 right here and 2 here, that will be 1/8. And then you have to integrate 1, and the integral of 1 is x. And then this 2 is now no longer here, that's gone. So you need to integrate cosine 4x. So once again, cosine 4x, the integral is sine 4x. And of course, you need to divide by 4. So now you can distribute it and kind of simplify because you have a 1/4 x and a 1/8 x. Can you see that, right? Coming from the first piece, right? So because of that, it's better to distribute here 1/4 x minus 1/8 x. And then when you distribute the 8 inside this, you get 32. So you get 132 and then sine x. So 1/4 8 and 1/8 x subtract will give you 1/8 x, right? Minus 132 sine 4x plus c. Alright, that's the answer. So this is the answer. Okay. Alright, okay, so once again our technique is what to do when you have both powers even, cosine and sine, but we're talking about only even powers. There's no way out rather than to use, so let me kind of change that now back to x, then to use the double angle formula. So what you do is you have two formulas, one for cosine squared x, another one for sine squared x, and you do that and you put that in and you integrate. So the philosophy is that you convert the square into a double angle because it is easy to integrate the double angle because the integral of cosine 2x is sine 2x divided by 2. Alright, that's it for today. Okay, thank you for watching.